In this video, we'll learn how to calculate the effectiveness of a counterflow heat exchanger using the NTU-Effectiveness method. Let's start by drawing the heat exchanger schematic. Here is a schematic of a counterflow heat exchanger. We have hot fluid flowing left to right and cold fluid flowing right to left. The overall conductance UA links the two streams. We know that UA is 8,000 BTU per hour per degree Fahrenheit. The hot stream capacitance is 4,000 BTU per hour per degree Fahrenheit, and the cold stream capacitance is 6,000 BTU per hour per degree Fahrenheit. Next, we compute Cmin, Cmax, the capacity ratio CR, and the number of transfer units NTU. For a counterflow exchanger with capacity ratio less than 1, the effectiveness epsilon is given by this formula. Substitute NTU equals 2 and capacity ratio equals 0.667. The exponent NTU times 1 minus CR becomes 2 times 0.333, which equals 0.667. Compute the exponential term EXP of negative 0.667, which is approximately 0.513. The numerator is 1 minus 0.513, which equals 0.487. The denominator is 1 minus CR times 0.513, that is 1 minus 0.342, which equals 0.658. Therefore, epsilon equals 0.487 divided by 0.658, which is approximately 0.740. Looking at the choices, the closest value to 0.74 is 0.8, which is choice C. So the effectiveness of this counterflow heat exchanger is most nearly 0.8, or choice C. This completes our NTU effectiveness calculation example.